Good morning, good afternoon, or good evening, depending on when you're watching this video. We're going to start by looking at sketching the graph given the function. We know how to sketch the graph given the function. If we were given y equals x squared minus 4x minus 12, and you were asked to sketch that graph, I'm sure you would know that it's a parabola. And we could find where it crossed the x-axis, because we know that it crosses the x-axis when y is equal to 0. So if we substitute that in, our y equals 0, we would have a quadratic equation to solve. And we know that we would factorise that, and that we would find two solutions, x equals -2 or x equals 6. We also know that it is a parabola and that it's going to be a U-shaped parabola, because the coefficient of your x squared term is positive. So putting these two things together, we can quickly provide a sketch of the graph. That's a possible sketch of y equals x squared minus 4x minus 12. So we were able to do that quickly. And that's prior knowledge. We did that in Mat 5. What we're going to do now is to find the function given the graph. So if we were given this function here, and we would have to work backwards. Again, we know it's a parabola, and we have the roots. So we know the roots are x equals -2 and x equals 6. Working backwards then, we could write x plus 2 equals 0 and x minus 6 equals 0. So one possible function rather, would be y equals x plus 2 times x minus 6. But that's only one possibility. It could be y equals 2 times x plus 2 times x minus 6. That would also give us zeros of -2 and 6. Y equals 3 times x plus 2 times x minus 6. In fact, a family of parabolas. So all we can say, given that graph, is that it belongs to the family of parabolas y equals k times x plus 2 times x minus 6. To find the particular parabola, we need another point on the graph. Let's do some examples then. In the following examples, we are asked to find the functions from the given graphs. So starting here with a parabola, we have the roots x equals -3 and x equals 2. So we can quickly establish that it would be, working backwards, x plus 3 equals 0, x minus 2 equals 0. So it belongs to the family of parabolas y equals k times x plus 3 times x minus 2. Now this time we are able to find the particular function from the graph because we have another point. We have the point 0, -12 is on the graph. So we know x is equal to 0 and y is equal to -12. So if we substitute that in, -12 equals k times 0 plus 3 times 0 minus 2. We would have -12 equals k times 3 times -2. So -12 is equal to -6k. K is equal to 2. So we have found the particular function. Y is equal to k times x plus 3 times x minus 2. We've worked out k is 2. So we're able to say y equals 2 times x plus 3 times x minus 2. Expanding the brackets then leads us to y equals 2x squared plus 2x minus 12. So in that example, because we had the additional point, we can find the family of parabolas and then the particular parabola. Let's do an example of a cubic. Now here we have three zeros, x equals -2, x equals 1, and x equals 5. So again, beginning by working backwards, x plus 2 is equal to 0, x minus 1 is equal to 0, x minus 5 is equal to 0. So we can say it belongs to the family of parabolas y equals k times x plus 2 times x minus 1 times x minus 5. And the other point this time is 0, 30. So x is equal to 0 when y is equal to 30. So substituting these in again as before, 30 equals k times 0 plus 2 times 0 minus 1 times 0 minus 5 would give us 30 is equal to 10k. So k is equal to 3. And again, we've worked out k. So it's y equals 3 times x plus 2 times x minus 1 times x minus 5. And we can work that out. If we work out the last two brackets, x minus 1 times x minus 5, that would give us x squared minus 6x plus 5. And this is again a Nat 5 skill, working out the next bit, a skill you had at Nat 5. And then finally, y equals 3x cubed minus 12x squared minus 21x plus 30. Good, that's a cubic. Now here's a reminder. If you were given that graph and you were asked to find the family of parabolas, it wouldn't just be x equals 3. That's sitting on the axis. Remember, that represents a repeated root. Again, you covered this in Nat 5 and in the course that we've done this year again, x equals 3 and x equals 3. So remember, sitting on the axis like that represents a repeated root. So let's try a third example. Now this is also a cubic, and remember this time there is a repeated root. So here our roots are x equals negative 4, x equals 2 and x equals 2 because of that repeated root. And again in the same way we could write x plus 4 equals 0, x minus 2 equals 0 or x minus 2 equals 0. Again, it's a family of cubics. Y equals k times x plus 4 times x minus 2 times x minus 2. Now we have another point on the curve. This time it is not where it crosses the y-axis. More often than not it is, but it's not always the case. This time our other point on the graph is 115. So x is equal to 1 and y is equal to 15. So again, with this other point, we go back to our family of parabolas and substitute these values in. So when we do that, we get 15 equals k times x is 1, remember, so 1 plus 4 times 1 minus 2 times 1 minus 2. So 15 is equal to k times 5 times negative 1 times negative 1. 15 is equal to 5k, so k is equal to 3. So the family of parabolas was y equals k times x plus 4 times x minus 2 times x minus 2. Using our other point on the graph, we were able to establish that k is equal to 3. So y is equal to 3 times x plus 4 times x minus 2 times x minus 2. Now I hope you find that helpful. That is finishing off the revision we did on polynomials. That was one aspect we still had to cover. And if you have any questions, please get in touch with me. Thank you very much.